Good day, class. Our topic for today has something to do still with adding vectors, but to be more specific, we are to discuss graphical and analytical methods. Here are the learning objectives. First, determine the resultant vector using graphical and analytical methods. And second, find the components of a resultant vector. From our previous discussion, you've learned the basic concepts of vector and direction, the conventions applied for representing vectors in terms of magnitude and direction. Also, we've tackled the process of how we add vectors in whatever dimension it is. Now, for today's focus, our goal is for us to learn the different methods for adding two or more vectors. Still, concept you've learned from the past is applicable for this particular focus. But what we're after here is for us to determine the magnitude and direction for the resultant vector in your two or more vectors given. Now let's have the first method, which is the graphical method. Now, to give you a heads up, this graphical method is further subdivided into two ways or methods. First is the polygon method, or in layman's term, we call it as head-to-tail method. Later, you will know the reason why we call it as head-to-tail method. Now, the other ways under graphical method, or the other method that we can apply in terms of graphical method, is the parallelogram method, which I will discuss later. Now, our focus for the meantime is your polygon method, in which I called it a while ago as your head-to-tail method. Because in this case, in this particular method, for graphical method, we have to strictly follow a certain scale. Things you've learned from the previous discussion for vector and direction. We have to represent again our vector using an arrow. The tail of it must be properly measured. That is for your magnitude. And for the direction, we have to use your protractor following the counterclockwise angle of rotation due to east in order for us to get the direction of the given vector. So what we have here are components, okay, components of the vector in order for us to get the resultant vector. So what we were after here is for us to get the summation of all the vectors, and we have to get the resultant vector by first, after you draw the first vector diagram, you have to connect the second vector diagram to the head of the first vector diagram. So the tail must be located directly to the head of the first diagram. So after that, you do the same for the rest of the given vectors. That's the reason why I highlighted here where the head of the first vector ends, the tail of the second vector begins. And that's the reason why we call it as head-to-tail method. Now, in order for us to get the resultant vector in this method, which is polygon method, we have to use the ruler. We have to measure the distance, okay, from the tail of the first vector diagram to the head of the last vector diagram. So we have to measure that in order for us to determine the magnitude of the resultant vector. Okay? And after you measure that, because you're following a certain scale here, that's the time that you have to convert it, okay, into real units. Now, in terms of direction, that's the time that we have to use your protractor. Same things Here, you have to measure the angle, okay, counterclockwise, angle of rotation from due east. Okay, and that's the time that we can have the direction of the resultant vector. Now, I mentioned protocols that we have to apply in terms of applying this graphical method, which is your polygon method. Here are the examples. For number one, having this scale, 2 meters is equal to 5 centimeters. We have this displacement 1 to 3. For 1, we have 2 meters to north. That's the direction. For displacement 2, we have 6 meters east. For the third vector, we have 8 meters south. For number 2, we have to still look for resultant vector of this 3 vectors. Your 20 meters 45 degrees, 25 meters 300 degrees, and 15 meters 210 degrees using this scale. 1 centimeter is equal to 5 meters. We're going to apply protocols for polygon method, and let's see if we can really determine the magnitude and the direction of the resultant vector. Now let's solve the example number 1. So we have to be mindful again of the scale. So we have 2 meters is equal to 5 centimeters. So we have to apply things you've learned during dimensional analysis in order for us to properly convert it to a certain scale. So d sub 1, we have 2 meters. For d sub 2, we have 6 meters. And for the d sub 3, we have 8 meters. So we have to multiply that to the fractional form given in a scale. So multiply to 5 centimeters over 2 meters. So we have to do that for all the displacement. Okay, so after that, we have to cancel similar units. Then we have to do the operation. So we have 5 centimeters. For d sub 2, we have 15 centimeters. And for d sub 3, we have 20 centimeters. Now let's write again our given and the corresponding converted value based on the given scale. So we have 2 meters to the north, and that becomes 5 centimeters. For d sub 2, we have 6 meters to the east, and that becomes 15 centimeters. And for the d sub 3, we have 8 meters to the south, and that becomes 20 centimeters based on the scale. Okay, and let's try to write it again, the scale, in order for us to properly visualize everything we have here in on the board rather. So 2 meters is equal to 5 centimeters. Now using the ruler, let's try to draw a Cartesian plane. So from that, we have to measure 5 centimeters using the ruler. 5 centimeters to the north, that is the direction. So we have to properly measure the length using the ruler. Properly place the ruler to its right calibration for 5 centimeters. Then let's try to put a label for d sub 1. Now let's work with the d sub 2. So this is head to tail method. So we have to connect on the head of the first vector diagram, the tail of the second vector diagram. So 15 centimeters. So we have to stop on 15 centimeters. Then we have to label that as d sub 2. Same things goes. We have to draw the next vector diagram at the end of the head of the second vector diagram. Okay, so that is 20 centimeters. We have to properly measure that up to 20 centimeters. Okay, so let's label it d sub 3. That is south. Now, from the protocol, we have to connect okay, the tail of the first vector diagram to the head of the last vector diagram. And let's try to draw a broken line here. And after that, so let's try to measure the resultant vector. Okay, using again the ruler. Okay, so be mindful of your measurement. Okay, so let's do the operation after we cancel similar units here. So we have 8.4 meters as our resultant vector for its magnitude. Now, using a protractor, let's try to measure the direction. So, okay, so using the protractor, properly measure it, and therefore, okay, our direction for this particular given is 45 degrees. Okay, so north, south, north, east, south, and west. In order for us to properly identify the correct location, that is south of east. Now let's have example number 2. So we have the scale, which is 1 centimeter is equal to 5 meters. And we have 20 meters for the first vector. Magnitude of it, we have 25 meters for the second and 15 meters for the third. So let's apply things you've learned from dimensional analysis discussion in order for us to properly convert it into the given scale for each of the vector. So 1 centimeter over 5 meters, multiply again 1 centimeter to 5 meters, and for the last 1 centimeter over 5 meters. So cancel similar units, then do the operation. So we have 4 centimeters, and for the second one we have 5 centimeters, and for the third we have 3 centimeters. Okay, now let's write our given and its corresponding converted scale. So we have 20 meters, that becomes 4 centimeters, 45 degrees. We have 25 meters, that becomes 5 centimeters to 300 degrees. And lastly, we have 15 meters na naging 3 centimeters to, with the direction 210 degrees. So write again the scale. In order for us to properly visualize everything we have in terms of the values for the given. So 1 centimeter is equal to 5 meters. Using the ruler, we have to draw a Cartesian plane in order for us to properly locate and orient our vector diagram. Now let's start with the first vector diagram. So measure first the angle, okay, for the direction using the protractor. So due to east, so that is 45 degrees. Measure it properly. So we have to put a dot in order for us to have an idea that that is a way for us to really have a right measurement for 45 degrees. Then using a ruler, measure 4 centimeters. Okay. Or we have to properly place our ruler on the dot. Okay. So 45 degrees for the angle. That is the first, okay, vector diagram. Let's draw the second vector diagram. So we have to make here at the end of the arrow, the head of the arrow, a small version of a Cartesian plane. Because we're doing that in order for us to measure the angle, which is 300 degrees. Okay, so we know it already. Where can we properly locate the 300 degrees? So, done with the first quadrant, second quadrant, and the third quadrant, 270. So, add na lang tayo ng 30 degrees in order for us to have 300 degrees. Okay? Same procedure, make a dot para that gives us an idea na that is for 300 degrees. Then measure the length of the tail of your arrow for the second vector diagram. 5 centimeters pa rin. Okay. So that is for the 300 degrees direction. Okay, then let's draw again a small version of a Cartesian plane in order for us to properly measure still the angle, which is 210 degrees. So using a protractor, we know now we're done with the first quadrant, second quadrant, and third quadrant, 180. So measure na lang tayo ng kulang sa 180 to reach 210. Okay? So using a protractor. So put a dot para alam natin na yan yung palatandaan natin for the 210 degrees. Measure the length of the tail of your arrow, which is 3 centimeters. There you go. So using a ruler, then that is now for your 210 degrees. Same procedure, we have to connect, okay, the tail of the first vector diagram to the head of the last vector diagram. And we have to measure the length of that in order for us to get the magnitude of the vector, resultant vector rather. Okay, so let's try to measure the magnitude of our resultant vector. So that is 4.1 centimeters. Now that is the magnitude. Now we're not yet done because we have to convert that into its real unit rather, using the scale. 1 centimeter is equal to 5 meters. So do the dimensional analysis procedure in order for us to properly convert it into its real unit. So 5 meters over 1 centimeter. We have to multiply that to 4.1 centimeters. So cancel similar units there. Then do the operation. 4.1 multiplied to 5 divided by 1. We have 20.5 meters. So that is the resultant vector. And that signifies a value for magnitude. Now let's try to identify the angle of rotation for the direction. We're done with the first quadrant, second, and third. So we have to orient it to measure, okay, from the, okay, to where you could see your vector diagram for resultant vector. So measure that. What you have there is a value 4. So that is 312 degrees because we're done with the first quadrant, second, and third. So we just simply add na lang yung values for that particular line for the resultant vector. So to identify the direction, okay, based on the convention, so 312 degrees is of south. So that's our answer. Now let's have the next method under graphical method, and that is the parallelogram method. This is similar with the head to tail method in a way that we follow a strict scale as we draw the given vector diagram. But in this case, the main difference of this method to your polygon method is that the given here is the resultant vector. What we're after here is for us to look for the components of the vector. Because as we look back again to the polygon method, what we're after there is to determine the resultant vector having the given okay, or having the different components. So we have to sum up everything in order for us to get the resultant vector, the magnitude of it, and the direction. Now, in parallelogram method, what we have or the given is just the resultant vector. We have to look on the components of it. There are steps that we have to follow for this method of vector resolution. As mentioned earlier, we have to accurately draw the vector to a certain scale. So we have to properly measure the length of the tail, and we have to use the protractor in order for us to identify or to measure properly the given direction. So after that, we have to sketch a parallelogram around the vector. So in this case, beginning at the tail of the vector, sketch vertical and horizontal lines. Then you have to sketch horizontal and vertical lines at the head of the vector. So the sketch lines will meet to form a rectangle. And we know that a rectangle is a special case of a parallelogram. So that's the reason why we call this method parallelogram under graphical method, because what we have, as we draw horizontal lines and vertical lines to your resultant vector, is we produce a rectangle. Okay. Now, after that, we have to label the sides of the parallelogram. In this case, what we're using, the variables that we have to use in order to properly label the sides of the parallelogram are the x and the y. So you might wonder why we have to use x and y. Simply because we're still using here Cartesian plane in order for us to properly orient our resultant vector. After that, we have to measure, okay, the length of the sides and convert that into its real units. That's how parallelogram method works. Now let's apply the steps discussed in order for us to do these examples, to work with these examples. For number one, we have to look for the components of the resultant vector, which is 5 meters, 30 degrees is of south, and the scale is 2 meters is equal to 10 centimeters. Now for number two, same procedure. We have to look for the components of the given vector, which is 15 meter per second. So 15 meter per second, 60 degrees, and the scale that we have to apply is 1 centimeter is equal to 10 meter per seconds. Okay, let's have example number one for parallelogram method. So the resultant vector is 5 meters. Direction is 30 degrees east of south. Now the scale is 2 meters is equal to 10 centimeters. So that's the scale that we have to apply for us to convert 5 meters to centimeter. So using dimensional analysis discussion, you can definitely go ahead and do the conversion thing. So 5 meters multiplied to that fractional form, 10 centimeters over 2 meters. Cancel similar units. Then do the operation 5 times 10 divided by 2. That gives us 25 centimeters. Now let's write again our converted value for 5 meters. That is 25 centimeters. 30 degrees east of south. So, okay, let's draw a Cartesian plane in order for us to properly orient the scale value. So 25 centimeters, 30 degrees east of south. That gives us an idea that is found in the first quadrant. So measure first the angle of rotation, 30 degrees. So using a protractor, Put a dot as a mark na nandun ng 30 degrees. So, measure tayo ng 25 centimeters using our ruler. Okay, or properly place the ruler. So, up to 25 centimeters only. So, let's draw a line for the magnitude of the resultant vector. Now, let's try to draw broken lines here to reveal a parallelogram figure in this Cartesian plane. So, this is parallelogram method. So, for the first axis of this Cartesian plane, and likewise on the second, tail to head, we have to draw broken lines, and we have to do on the other side of the vector diagram. We have to still draw a broken lines. And later, after we draw broken lines, we have to measure these broken lines in order for us to really, determine the components of this resultant vector. Okay, so for the y, we label that as y, and that part we label it as x. So we don't know exactly the value of it. That's the reason why we have to still measure it using a ruler. So for the y, we have be mindful of measuring it. We have 12.5 centimeters. And for the x, we have, so let's see, place the ruler properly in order to measure it. So we have now a value for x, which is 21.7 centimeters. Okay, let's write again the scale in order for us to write the measured components into real units or real unit. So for the y, that is 12.5 centimeters. So do dimensional analysis procedure in order for us to convert it into real units. 2 meters over 10 centimeters. We have to multiply that to 12.5 centimeters. Okay, so cancel similar units. What we have there, 12.5 multiplied to 2 divided by 10. So our answer there is 2.5 meters. Now for the value of x, that is 21.7 centimeters, we have to multiply that to 2 meters over 10 centimeters. So cancel similar units. What we have there, after we do operations, is 4.34 meters. Now that's the value for the x and for the y components. Now let's have number 2. So we have a resultant vector as a given, which is 5 meter per seconds, 60 degrees as the direction. So the scale is 1 centimeter is equal to 10 meter per seconds. So we have to do dimensional analysis procedure in order for us to change 50 meter per second into centimeter. So we have to multiply that fractional form to 50 meter per seconds. 50 meter per seconds multiply to 1 centimeter over 10 meter per seconds. Cancel similar units. 50 multiplied to 1 divided by 10 is 5 centimeters. Okay, so let's draw a Cartesian plane again. So we still have to follow the steps for parallelogram method. So 60 degrees is still on the first quadrant. So 60 degrees first is the one that we have to measure using the protractor. So ganun pa rin gawin natin. We have to write a mark or a point para an indicator that is 60 degrees. Okay? So now that's the time for us to use the ruler to measure 5 centimeters. Still, we have to consider pa rin yung ating mark for the degree, for the direction. So once properly measured and oriented na our ruler, that's the time that we have to draw a line na. There you go. So up to 5 centimeters only. Then, the next step that we have to work na is to really double check again if that is 60 degrees. Okay, make sure that everything is properly measured para hindi tayo magkamali in terms of measuring the length of the components. So 60 degrees. So let's draw broken lines for the sides. That is in reference for our components. Okay, so as well as on the other side. And that's those broken lines, we have to measure that using still the ruler. So that is for the X and for the Y. We don't know the values yet. But good thing we have a ruler, we can measure that. So we see na an indication that this is really a parallelogram method. So measure the X, okay, the variable X for that side. So that is 2.5 centimeters. And for the Y, on that side, so that is 4.3 centimeters. So what we have to do is to convert it into real unit. So start writing again the scale. 1 centimeter is equal to 10 meter per seconds. Now write it into a fractional form that can be used to really convert those measured value. So 10 meters over 1 centimeter. 10 meter per seconds over 1 centimeter. So for the Y, we have 4.3 centimeters multiplied to 10 meter per seconds over 1 centimeter. Cancel similar units. So 4.3 multiplied to 10 meter per seconds over 1 centimeter is 43 meter per seconds. Now for the X side of that parallelogram method, 2.5 centimeters multiplied to 10 meter per seconds over 1 centimeter. Cancel similar units. Okay, so what we have there after we do the operation, 25 meter per second. So those are our answers. Now to some of the different methods under graphical method, your polygon and the parallelogram methods, the only thing that you have to remember there is we really need to follow a strict scale in order for us to properly measure the magnitude and the direction, making it a graphical method. Now, the next method that we have to do in order for us to work and determine the summation of 2 or more vectors is your analytical method. Now, what makes it different to your graphical method is in this method, no need for you to use your ruler, your protractor, okay, to measure the length, the direction of the given vector diagram. And that's the reason why we call it as analytical, because we're just simply using mathematical tools. To be more specific, you'll be using here Pythagorean theorem and the trigonometric functions. Okay? Now, as I mentioned, it involves using trigonometric functions in order for us to properly determine the components of the vector. Okay? So, also, these methods, we have to employ certain steps in order for us to properly measure your magnitude and the direction of the given vectors, so for us to get the correct resultant vector. So in here, we have to identify the components of the x and the y. So this is important that we have to take note that in quadrant 1, the values of the x and y components are always positive. Now for the quadrant 2, values for the x the value for the x component is negative, for your y positive. For the third quadrant, both of them are in negative signs. Now for quadrant 4, so x component is positive while the y component is negative. Here, we have to correctly identify the components, individual components for your x and y. Take note also the direction. Remember that direction will give you the sign. If that is north, therefore that is positive. If that is south, that is negative. If that is east, positive. For west, that is negative. So you have to be mindful about the given direction in order for you to properly write the sign for that given magnitude. Okay? So after identifying the components in in x and in y component, the next step that we have to do is to add them. Add the values for the x components algebraically. You have to be mindful about the signs. Now for the y component, we have to do the same. We have to add them algebraically. Now after that, the calculated, the summation of the x and the y, that's the values that we have to use in order for us to solve for the resultant vector in terms of its magnitude. So that's the time that we have to use the Pythagorean theorem. Okay, so in the given examples, you will know how we can apply these rules. Okay, so and also take note, class, that for the direction, we have to use your trigonometric function. Okay, so you will learn more about those steps once we apply that in these examples. For number 1, we have to solve for this problem. A student drives his car 6.0 kilometers north before making a right-hand turn and driving 6.0 kilometers to the east. Finally, the student makes a left-hand turn and travels another 2.0 kilometers to the north. What is the magnitude of the overall displacement of the student? So again, we have to apply the steps mentioned earlier in order for us to properly solve for the resultant vector. Now for number 2, an ant crawls on a tabletop. It moves 2 centimeters east, turns 3 centimeters 40 degrees north of east, and finally moves 2.5 centimeters north. What is the ant's total displacement? For number 3, solve using analytical method to get the resultant forces of the following: 20 newtons west, 10 newtons 60 degrees north of east, and 50 newtons 30 degrees west of south. Now let's have example number 1 for analytical method. First step, we have to make a table for the x component and also for the y component. So write the given 6.0 kilometers north. Second given is 6.0 kilometers east. And the third one is 2.0 kilometers to the north. So let's identify the x component and the y component of the first vector given. So 6.0 kilometers to the north, that is for the y component. So no x component for that kasi north lang yon. Okay? So let's do the same for for the second given, 6.0 kilometers east is on the x component, right? So that is still positive, okay, for the first quadrant, your east. So 0 for the y component. Now for 2.0 kilometers north, y component still positive because that is found on north. So 0 for the x component. So we have to be mindful about that. And then let's try to add the values for the x component. So that is 6.0 kilometers. And for the y component, we have to do addition algebraically. So 8.0 kilometers. Now let's continue our solution. So in order for us to get the magnitude of the resultant vector, let's use the Pythagorean theorem. Plug there 6.0 kilometers square of we have to square that, plus 8.0 kilometers we have to square that also. So get the square of 6.0 kilometers and 8.0 kilometers, then we have to add them. So the answer there is 100. We have to square that, 100 kilometers squared. So we have to square that in order to get the resultant magnitude. So that is 10 kilometers. So that is our magnitude value. And we do that, okay, we have that answer due to Pythagorean theorem. Now we have to get the direction. So let's use here, okay, the trigonometric function. But before that, we have to draw a Cartesian plane with a direction. And both of them are positive. So we have an idea that these are found on the first quadrant. So y component is 8.0 kilometers. The x component or your x-axis is 6.0 kilometers. So we have to look for the angle for the direction. So we have to use a Pythagorean theorem here, which is tan theta, because opposite over adjacent. Okay. So we have to get the value of the theta. So we have to transpose tan to the other side, making it angle theta is equal to tan arc, or arc tan rather. The value of opposite is 8.0 kilometers over 6.0 kilometers. So we have to do the operation for that in order to get the value. So divide 8.0 to 6.0, then multiply that to tan arc tan. So we have now 53.13 degrees. So the direction of that is north of east. Okay, north of east. Now we can have another direction kasi we don't know exactly saan itong value matatagpuan. So we can go ahead and look for the other side of the first quadrant. So that becomes 6.0 kilometers, your x component, and 8.0 kilometers for the y component. Okay, so angle of theta is equal to tan arc tan. So multiply that to 6.0 kilometers rather over 8.0 kilometers. Get the quotient of that, multiply that to arc tan. Okay. Or tan negative 1. So you have now 36.87 degrees. Now that is the other way around of north of east. That becomes east of north. So therefore, our resultant vector is, using analytical method, 10 kilometers. The direction could be 53.13 degrees north of east, or 10 kilometers still. Direction is 36.87 degrees east of north. So this is easy because no need for you to measure things here. Now let's have example number 2. So we have to make a table for us to properly identify the components for the x and the y. Okay, for the given. So we have 2 centimeters to east, 3 centimeters 40 degrees north of east, and last is we have 2.5 centimeters north. So focus muna tayo dun sa first given. So that is x component only, positive. So 2 centimeters. So for the y component, we don't have value for that. Now for 3 centimeters, 40 degrees north of east, we don't know exactly the position for the x component and the y components. So what we're going to do here is for us to identify the value for the x component and the y component using trigonometric function. Okay? So draw a Cartesian plane. So north of east is found on first quadrant, north of east. So we have to position that on the first quadrant. So draw a line that represents a vector diagram. So 40 degrees for the angle. So get the resultant vector magnitude is 3 centimeters. So we have to identify the value of the y component and also the x component. Okay, so here 40 degrees, that is we're given in 3 centimeters. So the opposite of that is y. Hypotenuse is 3 centimeters. So we have to work with those given in order for us to get the value of y. So that is sine, right? Sine 40 degrees is equal to opposite is y over hypotenuse, which is 3 centimeters. That's the reason why we use sine. So do cross multiplication in order to get the value of y. Y is equal to sine 40 degrees multiplied to 3 centimeters. So get the value of sine 40 degrees, then multiply to 3 centimeters. We have y is equal to 1.93 centimeters. We have to do the same for the x later. So for the meantime, we have to put 1.93 for the y component. That is positive because that is found in the first quadrant. Now for the x, so do the same procedure, adjacent over hypotenuse, right? In reference to the angle. So that is cosine. So cos 40 degrees is equal to x over 3 centimeters. Now cross multiplication in order for us to get the value of x. X is equal to cos 40 degrees multiplied to 3 centimeters. Get the value of cos 40 degrees multiplied to 3 centimeters. That's the answer for the x is 2.30 centimeters. So we have to put that on the x component for 3 centimeters, 40 degrees north of east. That is still positive because found in the first quadrant. So now let's move on to 2.5 centimeters north. So that's easy. So that is found on the y component, 2.5 centimeters positive still. For the x, we don't have value for that. Okay, so let's try to add the values for the x component algebraically. So we have 4.30 centimeters. Also on the y component, we have 4.43 centimeters. Now let's continue our solution. So we have to use the summation of the x component and y component in order for us to get the magnitude of our resultant vector. So use the Pythagorean theorem. 4.30 30 centimeters, we have to square that. Add that to 4.43 centimeters. We have to also square this. Okay. So we have to add them and then get the square root of it. Okay, so we have a resultant magnitude, which is, okay, So we have to erase that. Okay, we have to move directly now. So we have 6.17 centimeters as the magnitude for this resultant vector. So we have to draw a Cartesian plane. So we know for a fact that that is still found in the first quadrant based on the sign. So we have x component 4.30 30 centimeters, for the y 4.43 centimeters. So we have to look for the value of the direction or the angle. So by merely looking on it, we have to use tan theta, opposite over adjacent, because those are the values we have. Now, so we have to transpose the word tan on the other side, so that becomes angle theta is equal to arctan. Okay, so the quotient of opposite over adjacent, your 4.43 centimeters divided to 4.30 centimeters. Quotient of that, then we have to multiply that to arctan. So that gives us, okay, an answer which is 45.85 degrees. Okay, and to be more exact, north, east, southwest, that is found on north of east, no, yung buka ng angle natin. We have to also look for the other side kasi we don't know exactly the position of it, para we can have two answers lang for the direction. So y and x still, that is same in terms of values rather. So our tan theta is equal to arctan multiply to quotient of your 4.30 centimeters over your 4.43 centimeters. So nagkabaliktad lang sila on the first procedure we had. So angle theta rather is equal to 44.15 degrees. So the position now is, so let's write again the resultant magnitude, 6.17 centimeters, 45.85 degrees north of east, or so 44.15 degrees naman, we have to add that to 16.17 centimeters. So that is found on east of north. Okay, so east of north. So you can have two answers for the direction. Now let's have number 3. So we have to make a table again and look for the value of the x component and the y component. So we have 20 newtons west, so that is automatically found on the x component. West is negative, so we have to be mindful about our sign. So there is no value for the y component. So 10 newtons, 60 degrees north of east, so we have to identify the component for x and y. So we have to draw a Cartesian plane, and that is found in the first quadrant, north, east, south, and west. Okay, so 10 newton is the value of the magnitude, 60 degrees is for the direction. So that is y component and x component, and we don't know yet the values for those components. Okay, so let's use trigonometric function here. Let's use the position of the given 60 degrees. So sine 60 degrees in order to get the value of y over hypotenuse, which is 10 newtons. So cross multiplication, you have y is equal to sine 60 degrees multiplied to 10 newton. Okay, so sine 60 degrees, the value of that multiplied to 10 newton, the answer is y is equal to 8.66 newton. Okay, so let's do the other way around for the other component x. That is cos 60 degrees kasi nga adjacent over hypotenuse based on our given. So you know naman how we do that. So cos 60 degrees multiply to 10 newtons. Whatever the value of cos 60, you have to multiply that to 10 newtons. So the answer for x is 5 newtons. So that is on the first quadrant. So all of these values are in positive sign. Okay, so let's write it there on the y component. 8.66 newtons. 5 newtons for the x component. We're okay now for your number 2 given. Now, same procedure for third given. We have to draw a Cartesian plane. West of south is found on the third quadrant. So we have to make third quadrant as big as possible para dun tayo mag-focus. So 30 degrees west of south. So draw a broken line for the x component. You don't know exactly yet and also for the y component. So we have to put here 50 Newton for the magnitude of the resultant vector. So opposite over hypotenuse for the x, sine 30 degrees x over hypotenuse, which is 50 newtons. So cross multiplication, you know the drill. X is equal to sine 30 degrees multiplied to 50 newtons rather. So is equal to whatever the value of sine 30, multiply that to 50. We have 25 newtons. Now let's solve for the value of y. Adjacent over hypotenuse cos 30 degrees is equal to y over 50 newtons. Now let's do the cross multiplication in order to get the value of y. So just an heads up lang mga anak, it is not always that for x is sine, for cos is y, or the other way around. We have to properly be mindful about the position of the given. So y is now 43.30 Newton. So we can definitely go ahead and put that on the x and y component, and we know that these are found on the third quadrant, so negative yun lahat. Negative 25 newtons, kahit di siya negative on the way you calculate it. Kasi nga, we have to be mindful about the direction. So 43.30 degrees Newton. Now let's continue our solution. Now we have to add the values for x component algebraically. So that gives us an answer which is negative 40 newtons. Now do the same for the y component, add it algebraically. And that will be used later for the magnitude of the resultant vector. Okay, the values for, or the summation of the x component and the y component. We have negative 34.64 Newton. So Pythagorean theorem for the resultant vector in terms of magnitude. So we have to get the square of negative 40 newtons and also the square of negative 34.64 newtons. Okay, and we have to add the values of those the values from that solution part, and we have to get the square root of it. You know naman how we do that in terms of the mathematical procedure. So resultant vector na in terms of magnitude is 52.91 newtons. So that is the magnitude of the resultant vector for this given. Now we have to work now for the direction. So negative found on the third quadrant, north, east, west, south. So we have to imagine that is found on the third quadrant. So let's try to determine the angle for that part. So we have to draw broken lines for the y and for the x. Okay, so y is negative 34.64 Newton and x is negative 40 newtons. So we have to use trigonometric function here, which is tan, kasi opposite over adjacent. arctan, we have to multiply that to the quotient of negative 34.64 newtons over your negative 40 newtons. So that gives you, you do the operation and multiply that to arctan. So you have 40.89 degrees. Okay, and the direction of that is south of west. Now, for the other side of the third quadrant, x and y, so opposite over adjacent. So angle theta tan arctan multiplied to the quotient of your negative 40 newtons over negative 34.64 newtons. We have to do that in order for us to really picture out the sides of that quadrant in terms of its value of the angle and the direction. So when you do that, you have the value which is 49.11 degrees. So that is west of south. So therefore, our answer now becomes 52.91 Newton, 40.89 degrees south of west, or 52.91 Newton, 49.11 degrees west of south. That's our answer for the last problem.